Exercise 227. Let's look at evaluating a triple integral where the solid is contained inside of this sphere which is provided to us here in the picture for some r, which is positive. Then if we want to come up with equations of that solid, E, we want to come up with 3 continued inequalities, and the first 2 inequalities will describe a projection of the solid. So let's go ahead and look at this base of the solid, and that's occurring in the xy plane. The xy plane has z equal to 0, so this outer boundary curve is the circle centered at the origin of radius r. So if we draw that, let's put some notation here. Let's call that d sub xy. We can draw a picture of d sub xy in the xy plane. Shade in dxy. And then write some inequalities to describe this region. The x's will occur between 0 and r. Pick an arbitrary x. Then you need to pick x between 0 and r. So those are hard bounds. This r is fixed. Those are hard bounds on x. So let's set up dxy as a type 1 region. We need 2 continued inequalities. We've written down 1 for the second one. Draw in a vertical line segment. And then find the smallest y value and the largest y value. The smallest y value is y equals 0. And the largest y value occurs on the bounding quarter circle. To express out the quarter circle, which is given by the equation x squared plus y squared equals r squared, we solve that equation for y, and we'll get y equals the radical, positive radical, of r squared minus x squared. So that's this bounding curve, and that's going to be the y-coordinate of that highest blue dot. Good. So now we have a description of a projection of the solid, d sub xy. Then if we want to produce this choice of x in our picture, remember that x's go from 0 to r, which in this picture r is equal to 2. And we've picked an arbitrary x, and then we've looked at a line segment, a vertical line segment, and then found the smallest y value and the largest y value on that line segment. Then, to figure out z's, you go ahead and you pick a point. Let's go with a white point. On that line segment, that point that you've picked has both an x-coordinate and a y-coordinate. So depending on that choice of x and y, let's figure out what z's are going to do. So that white dot occurs in the base of the solid E. So that means that z's will be allowed to be as small as 0. Let's now draw a vertical up and down line segment and then stop when we hit the sphere. Let's make another white dot there. So on that black line segment, z values are as small as 0 and then as large as whatever it is on the sphere. So the sphere is given by this equation. We solve that equation for z and find that z has an upper bound of r² minus x² minus y².